Hi folks, a little different way to take a video here, but I've already had a few students send me an email this morning asking about some of these concepts on handout 811 and when to use what equation. So I wanted to clarify one thing, and this will only be a real short video here, but it might help you out as you're going through. So we have a couple of equations for springs. Force equals kx for a spring. All right, we did the equilibrium problems where we had it on a spring and just had the mass at equilibrium. In that situation, force spring is not only equal to kx, but it's also equal to mg. So when it's in equilibrium, the forces are balanced. When it's not in equilibrium, so if we take an object and we compress the spring, this is a frictionless surface, force equals to kx still, but it's also equal to ma. You cannot use that to solve for any velocities though. And here's the reason. Those of you in calculus will understand this a little bit more. But this is not a constant force. So as this thing starts to decompress, right here we have the force at this point, but then the force starts to change as the spring starts to decompress. So what happens is the acceleration is changing. In our next video, we'll start to analyze some of that. We can find instantaneous accelerations. Like I could find the second that it's released, I can solve for A. I can find the acceleration at the halfway point. Obviously, once it's fully off the spring, the acceleration is 0. So what that means when we're solving for velocities is we have a changing spring force. Once again, we can take the next derivative and solve for it that way, but it's a little bit more complex. Luckily for us, energy in the spring is conserved, so that means whatever energy is stored in the spring here is equal to the kinetic energy after the spring has been fully released. So all you have to do to find any velocity, once you know how much energy is in the spring, all you have to do is just convert that over into kinetic, okay, and you can find the speed. Same thing, I think number 2 has this thing going up a ramp. Since everything is frictionless, all of the energy is going from the spring to kinetic to gravity. So once it gets up here at its highest point, I think we have an equation to solve for that height. Okay, so all of the energy goes from the spring to kinetic to the gravitational field as this goes through. Okay, hopefully that clarifies a few things for handout 811 and makes it a little bit easier.